Welcome to part 2 of 7.4. Let's keep reading. Because of rounding or experimental error, a compound's mole ratio sometimes consists of numbers close to the whole number instead of the exact whole numbers. In this case, the difference from the whole numbers may be ignored, and the nearest whole number is taken. Thus, diborane contains atoms in the ratio of 1 to 3. The compound's empirical formula is BH3. What is it basically saying? It's basically saying, hey, look, in the previous page, our math came up with 3.01. That's not a whole number, but the book's saying, hey, that's okay, because sometimes you make a mistake in your experiment or you round numbers and things don't come out quite perfect, but if it's close, you can just safely assume that's the right number, 3. Sometimes mass composition is known instead of percent composition. To determine the empirical formula in this case, convert mass composition, that's like how many grams for every 100, to composition in moles. Then calculate the smallest whole number ratio of atoms, mole ratio of atoms. This process is shown in sample problem M. Well, let's do a couple sample problems, L and M. Remember, you can choose which one you want to write down. I recommend doing both. So here we go. Let's do M. Make sure you have a nice fresh sheet of paper. I'll do that. And make sure you use a different color for your sample problems. And let's do number L first. And let's read. All right. Quantitative analysis, that means by measurements, shows that a compound contains 32.38% sodium, 22.65% sulfur, and 44.49% oxygen. Find the empirical formula of this compound. All right, so start with your givens, and you're given quite a few things. I'm just going to go ahead and write these down. Why don't you do that too? Don't be sloppy. Write them all down. Oh, but Mr. Worley, I know. What's our unknown? Empirical formula. So, what's our plan? Can you think of it without looking at the book? Basically, you're going to go for percent composition. That's what you start with. And here's our plan. Sorry for that. We're going to go from percent composition to mass composition to composition in moles to the smallest whole number ratio. And from that we can find our empirical formula. So first let's find out let's assume that we're dealing with, just like the book said, assume we're dealing with 100 grams of the sample. And so that means we're going to have 32.38 grams of sodium. Means we're going to have 22.65 grams of sulfur and 44.99 grams of oxygen. Mr. Worley, how did you get these numbers? Well, remember, 1% is 1 out of 100. And so if we're dealing with 100 grams, we can just say that 32.38% is 32.38 grams. Okay, so all of a sudden, ding, 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 this is our mass composition right here. I'm going to just put a little box around it. Okay, so we've already here. Now we're going to go to composition in moles. Well, to find out how many moles you got, it's pretty simple. Just multiply by a conversion factor that uses the molar mass. And you can see they've kind of done that right here. And let's just do it with me. Don't be lazy. Oh, sorry, you can't see. Do it with me. 22.65, 1 mole is worth 32.07, and we already know from previous problems that 1 mole of oxygen is worth 16.00 grams. We do our math and we come out with 1.408 moles of sodium. And we come out with 0.7063 moles of sulfur and 2.812 moles of oxygen. Okay, so here we go. We have now our composition in moles. I'm just going to put a little bracket around that and call that composition in moles. Sweet, composition in moles, got it. Alright, so now we just need to go to the smallest whole number ratio. And remember how we do that? We divide by the smallest one of these numbers because this is a ratio. Basically you have 1.408. For every 1.408 you have 0.7063, and for every 0.7063 you've got 2.812. So go ahead and just write these down on the bottom and divide by the smallest number, which is 0.7063. Be sure to put the atoms in there. What do these little dot marks mean right here? They mean ratio, or 2. So we just put them there to represent the ratio. You can see in our book they put the ratios here as well. And if you do the math, you'll come out with some numbers like this. Basically 1.99 sodium, 1 sulfur, 3.98 oxygen. Well, now they're very close numbers, so we can just go ahead and say that our answer then is 1.99, which we'll just say is 2 to every 1 sulfur to every 4 oxygen. So let's write our formula. I'd say it's sodium Na2 SO4. Can you tell me what that is? Sodium, what? Sodium sulfate. Very good. Nice. All right, so that's how we do sample problem L. Please change the video and keep moving on with me.